Hi there, welcome to this physics tutorial. We're going to solve the problem shown, and this is what we call a free fall problem. And so whenever we have something that's in free fall, we say that it's only moving in the vertical. And so when we look at our kinematic equations, we're going to use the ones with y. Those are the ones that we use for the vertical motion. So it says here a ball is dropped into a water well and a splash is heard 7.0 seconds later. Determine the depth of the well and how fast the ball was falling when it hit the water below. So let's start by listing out what we know. Well, it tells us that time, we'll label it as delta t, is 7.0 seconds. Now, if it's dropping, we can assume that its initial velocity was at rest, or 0 meters per second. Now notice I used the y subscript because we're in the vertical. And then the two things that it asks me to find is the depth of the well, which we can do by finding the vertical displacement, and then it wants me to also find the final velocity. Well, make sure we have F, not I. So the final velocity would be the velocity at which it hits the water below. So this is a little list of what we're given as well as what we know. So over off to the side, I'm going to list out my three kinematic equations, and these are the ones for the vertical motion, and so I'm going to use y subscripts. So we have one that's the final velocity equals the initial velocity minus g times delta t. Now remember, g is gravity because in the vertical the only acceleration is that due to gravity. The next one is the vertical displacement equals the initial velocity times time minus 1/2 g times the time squared. And then the last kinematic equation is the final velocity squared is equal to the initial velocity squared minus 2g times the displacement. So from these kinematic equations, I need to go about figuring out our delta y and our final velocity. So let's do the delta y first. Well, we need to find one of these equations that has delta y in it. So this bottom one has delta y. We know what gravity is. We have the initial velocity, but we don't yet know the final velocity. So this equation has too many unknowns. So let's check this equation. We want delta y, we know the initial and time, we know what gravity is, and we know time. So we have enough information to use that second equation. So I'm going to write that over here, delta y. Our initial velocity then was 0 meters per second. Our time was 7 seconds. But remember, this will end up canceling out in our next step because 0 times anything is still 0. Gravity is 9.8 meters per second squared, and then our time squared would be 7 seconds squared. So like we said, this will cancel out because 0 times anything is still 0. And when I plug the rest of this into my calculator, don't forget that square, I end up getting negative 240.1 meters. And the reason it's negative is because this ball is falling downward. So it makes sense that it's negative. But to answer the question, they just want the depth of the well. And so the depth of the well, we would say then, is about 240 meters because we would list a depth in positive meters. But keep in mind that the vertical displacement should be negative. So that's the answer to the first question. And then they ask us to find the velocity, or how fast the ball was falling when it hit the water below. So that's our final velocity. So looking at our equations, this first one here, let's check. It has final velocity, we know the initial, we know what gravity is, and we know time. So this one seems like it should work. So my final velocity equals my initial velocity. So whoops, that's 0, right? And then our g, we said, was 9.8 meters per second squared. And our time, again, is 7 seconds. So 0 is just 0. And when I plug this in to my calculator, I end up getting negative 68.6 meters per second. And this also makes sense that it's negative because it's falling. Downward motion in the vertical implies negative. So if it's falling, we expect the velocity to be negative. So there you have it, a problem on free fall. So remember, these are the kinematic equations that we want to use whenever an object is falling vertically or if something's being shot straight up and then coming straight back down, we consider those types of problems free fall. So find some problems similar to this to work on these skills. Good luck!